Hello everyone, myself Dipti Usse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Alandi, Pune. Today's our discussion topic is encoder-decoder using sequence-to-sequence model. Now let us understand what is the sequence-to-sequence model. In previous session, we have discussed recurrent neural network model like LSTM, GRU, which are effective for time series forecasting, speech recognition, and natural language processing. The sequence to sequence model, that is abbreviated as a seq to seq models, are special class of the recurrent neural network which are extended to solve the complex language related problems like machine translation, question answer, chatbot, and text summarization. Now in this diagram you can check the applications of the encoder sequence to sequence model. The application like machine language translation, text summarization, and chatbot. In sequence machine translation, the input is given in one language and it will translate it into another language. Means input will get in the one form and you are displaying the output in sequence. Then text summarization, I will get the paragraph of 1000 word and you are summarizing into 500 word using seq to seq model. Also, there is one more application of chatbot. We are asking something, a question, and you are getting the reply in the form of sequence. Here you can see the example. The input is given in English language where this language is translating into other language. Now here in sequence to sequence model, we are using the encoder-decoder network model. Now what is the role of encoder? There's encoder accept the input in the form of sequence and create the contextual information which store the representation of the encoded information of the input, and which is you will be the input for the decoder, and decoder will decode the contextual information as the input and generate the output sequence. Both encoder and decoder are typically LSTM model, and this encoder read the input sequence, summarize the information in internal state vectors such as hidden and cell state vector in LSTM by discarding the output, whereas in decoder is an LSTM whose initial states are initialized to the final state of the encoder LSTM, and using these initial states decoder starts generating the output sequence. Now let us understand the flow of encoder-decoder. Decoder undergoes the training and inference using teacher forcing for faster training output of from previous time step as the input at each time step, whereas the encoder automatically converts the input sequence into state vector which are then passed to the decoder language model based on the initial state. Now in this example you can see the input is given. Already we have discussed the architecture of LSTM. Now here in LSTM, the input is given at every time step. The hidden state value of the previous state will be the input for the next state along with its current input. The output is generated in encoder, but in encoder we are discarding the output and here generating the contextual information which store the which consists of the hidden state information of the successive time step module. Now here this is the output is ignored in encoder, only it will focus on the contextual information of the input. Now here the context, the value this vector is generated by the encoder, means this is the encoded information of the input sequence. Here this context value will be passed through the decoder as an input, and this input is provided to each and every time step in a decoder. Now role of decoder, the whatever context is used as input in decoder, where the context is the final hidden state of the encoder. The first decoder cell that context information which will the prior hidden state information, also it is called as the latent space, or also it is called as the thought vector, which store the contextual information of the encoder. Okay. Now here let us discuss one architecture of encoder-decoder. Now in architecture of encoder-decoder, the input will be given through the embedding layer. Now input will be given at every time step through the embedding layer. These are the embedding layer. Now after accepting the input, every LSTM or RNN or the GRU ca- co- computes its hidden state by considering the current input and the hidden state of the previous cell state and hidden state, and generate the output, and also it will generate the value of h and c, that is a cell state value and hidden state. And here in encoder we are discarding this output and we are giving this storing whatever the contextual information stored by previous cells that will be carry forwarded and which will hold the important encoded information of the input through the decoder. In decoder, the whatever output generated by context encoder, this encoded input in the form of context will be the given to the each input at every time step in decoder and generates the output, and at the end last hidden state value will be discarded by decoder. The whatever output is generated in decoder, that will be the input for next time step. Suppose y1 is generated, now this y1 will be the input for the next time step value. Okay, the training data consists of the set of input sentences and their respective output sequences. Use cross entropy and loss in decoder and encoder-decoder architecture train end-to-end just as a RNN language model. Now let us discuss encoder-decoder model for Marathi neural machine translation, where we are translating from one language to another language. Now here this will be the input. This is the encoder architecture. The input, suppose one sentence is given. Now here there is one sentence. This sentence in Marathi English, Rahul is a good boy, and it is converted into Rahul changla mulga ahe. This is the ground truth level. Okay, here we have to translate this English sentence into Marathi sentence. Here source language is Rahul and English, and Marathi is a target language. Now this is the encoder phase. Now in encoder phase, the complete sentence will be broken down into token. Now here there are 5 token. One LSTM will execute for each sequence. Okay, and at every time step value it will generate the h1 and c1, that is hidden state and cell state value, and which will be used to calculate the hidden state and cell state of the next state. And in this way here this h5 and c5 which will hold the contextual information or encoded information of input sequence. Now here this input encoded sequence, whatever input output generated by encoder, that will be the output for the decoder. The vector which is vectors like hk, that is hidden state and cell state generated by encoder, is called as the encoding of input sequence, and as they encode or summarize the entire input in a vector form. Since we'll starting generating the output once we have read the entire sequence, yi, the output of the encoder at each time step, will be discarded. Now next step, that is a decoder. Now in decoder, let us understand in diagram. Now this is the decoder architecture. In decoder, whatever output generated by encoder will be the input for the next step, along with the along with the ground truth sequence. Now this is the decoder training phase. In decoder training phase, here H0 and C0, this is the contextual information or encoded input sequence generated by encoder. That will be the input for decoder. Rahul is good boy. For this, the output will be, ground truth output will be Rahul changla mulga hai. That will be translated into Marathi language. Now this is the initial state of the decoder as initialized to the final state of encoder, that is the contextual information. Now here start and end token will be added for the target language at the start, and at the end these total tokens will be added. The input at the each time step, actual output and of the previous time step, this is called as the teacher forcing method in faster and efficient training of the network. Now for Rahul is a good boy, output should be should be the ground truth. This should be the output. Means here in decoder in training phase, the teacher forcing method will be used that will force to the system For Rahul is a good boy, for this input sequence, Rahul changla mulga hai, this should be the output. Okay, now here based on the ground truth value, here we are forcing to the end model to predict the next output with respect to the ground truth level. Now here for after start, next word should be appear, that is the Rahul. That will be the next input, that's output will be the next input for the next time step. Now again changla output will be generated, that will be the input for the next step. Means in teacher forcing method, decoder forces to decoder predict the output based on the ground truth level. Now here this method we are using, we use this technique, that teacher forcing, wherein the input at each time step given as the actual output from the previous time step. Now this is the entire training process of the encoder decoder, can be summarized in one diagram. Now here this is encoder, Rahul is a good boy, this is the source language. Here output will be discarded, focusing on H0 and C0, that will be the contextual information which will store the important information from the all layers, and then set final state of the encoder as the initial state of decoder. This will be the input. Now here we are using teacher forcing method to force the decoder to predict the output based on the ground truth level and generates the output at output level. Now let us discuss the inference model. Now in training model we are using teacher forcing method, but teacher forcing method we cannot use for the inference mode or testing mode. Now let us understand setup is required for the testing or inference. Already we have stated LSTM plays important role of reading the input sequence and generating thought vector, that is HK and CK. Now here the decoder now as a predict entire output sequence given as thought vector. Now this is the input, Rahul is a good boy and Rahul changla mulga ahe. Okay, this is the expected output. Here ground truth label is not given in a testing mode. Now here in testing mode, there is no ground truth label. Now at every time step, the hidden state and cell state will be generated in encoder for the given input, and here this will be the input for the next time step. Now for here HK, now here expected outcome is Rahul at time step, that will be the output. Now here already, if it is already trained, then start generating the output sequence in a loop word by word. Now at time step T1, this is the testing model example, T2, T3, at every time step input will be given and generate the output. Now here in inference algorithm, that is a testing, during the inference will generate one word at a time, thus decoder LSTM called as a in loop, every time processing only one time step. The initial step of the decoder are not to final state of encoder. The initial input to the decoder always start with start token and end with end token. At each time step, the model preserve the state of decoder and set them as initial state for next time step. Now this is the overall architecture of encoder and decoder, which is used for the machine translation example. Also we can use this encoder-decoder model for text summarization, image captioning, where we are using this encoder-decoder using different types of algorithm like CNN, bi-LSTM, that is bidirectional LSTM, RNN or GRU. This is all about the encoder-decoder model. Thank you.